Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello everyone. It's great to have you here as we dive into the fascinating intersection of neuroscience and artificial intelligence. To start, could you explain how the principles of human long-term memory, particularly the roles of the hippocampus and neocortex, inform the design of retrieval frameworks like HippoRAG for large language models?
To understand how the principles of human long-term memory inspire the design of retrieval frameworks like HippoRAG, let's think of our memory like a big library. In this library, the neocortex acts like the shelves where books are stored. Each book represents a piece of knowledge or an experience we've had. The hippocampus, on the other hand, is like a librarian who keeps track of where every book is located and can quickly find it when we need it. It uses a special index that connects the titles of the books with their locations on the shelves. When we create HippoRAG, we're trying to build an artificial library system that mimics this human memory. First, we have an instruction-tuned large language model, like a smart librarian, that extracts important information from a collection of texts and organizes it into a knowledge graph, which is like a big index of ideas. This is similar to how the hippocampus creates its index. When a new question or request comes in, HippoRAG identifies the key concepts, like themes or keywords, from that question. It then uses the artificial index to find the right books or information it needs, just like the librarian would find the correct book based on the title or topic. This process not only helps HippoRAG remember lots of information efficiently, but also allows it to retrieve knowledge quickly, much like how our brains pull up memories when we need them. By using this method, HippoRAG can answer questions better and faster, making it very effective in understanding and generating responses.
That analogy of the library and the roles of the neocortex and hippocampus is quite enlightening. Could you elaborate on how HippoRAG integrates the Personalized PageRank algorithm within this framework, and what specific advantages it brings to the retrieval process in large language models?
HippoRAG incorporates the Personalized PageRank, PPR, algorithm into its framework to enhance the retrieval process, and we can think of it like a treasure map. Imagine you have a map of a park with hidden treasures, pieces of information, scattered throughout. The PPR algorithm helps HippoRAG find the best paths to these treasures based on a starting point or a query, much like how you would explore different paths to reach your desired treasure quickly. When a question comes in, HippoRAG uses the key concepts from that question as starting points on the map. The PPR algorithm then looks at the knowledge graph, which is like a network of paths connecting different pieces of information to discover relevant subgraphs or areas where the answers might be located. This means it can explore various routes in one go, instead of taking multiple trips, which is what traditional methods often do. The specific advantages of using PPR in HippoRAG are quite significant. It allows the system to perform what we call single-step, multi-hop retrieval, which means it can connect the dots between different pieces of information in one swift action, rather than making several attempts. This results in better performance on tasks like answering complex questions, making it quicker and cheaper compared to older methods that require many steps. In summary, by integrating the Personalized PageRank algorithm, HippoRAG becomes like a highly efficient treasure hunter, capable of navigating its map of knowledge quickly and effectively, ensuring it finds the information needed without unnecessary detours.
That's a compelling way to describe the role of the Personalized PageRank algorithm, given the improved efficiency and performance of HippoRAG in comparison to existing retrieval-augmented generation methods. What specific results or metrics were observed in the multi-hop question answering tasks that highlight these advantages?
HippoRAG shows remarkable improvements in multi-hop question answering tasks, which can be likened to solving a puzzle where you need to fit several pieces together to see the full picture. In this case, when HippoRAG was compared to existing retrieval-augmented generation methods, it outperformed them significantly. Specifically, HippoRAG achieved enhancements of around 11 to 20 points in performance metrics like R at 2 and R at 5 on popular benchmarks like Musique and Tualaki Multihopka ... These metrics basically measure how well the system retrieves the correct answers among the top retrieved information, similar to how a student gets points for correctly answering questions on a test. Additionally, HippoRAG can perform multi-hop retrieval in a single step, making it much more efficient. This means it can gather all the necessary pieces of information in one go, rather than having to take multiple steps to find them. In practical terms, when looking at the success of retrieving all supporting passages for a query, HippoRAG showed an increase of 3% to 6% on Musique and 20% to 38% on Tualaki Multihopka. This suggests that HippoRAG is much better at collecting all the relevant information needed to answer complex questions, rather than just part of it. Overall, these results indicate that HippoRAG is like a master puzzle solver, completing complex tasks with fewer moves and retrieving more pieces of the puzzle at once, which enhances its overall efficiency and effectiveness in answering questions.
It's impressive to see such substantial improvements in performance metrics. Beyond these enhancements in retrieval efficiency and accuracy, can you explain how HippoRAG addresses the challenges of catastrophic forgetting that large language models typically face when integrating new information?
HippoRAG addresses the challenge of catastrophic forgetting in large language models by employing a method that mimics how our brains integrate new information without losing track of what we already know. Imagine a growing library where new books, new information, are constantly added. If the librarian, representing the language model, only focuses on the newest arrivals, they might forget the older books. However, HippoRAG uses a special way to maintain both the new and old information effectively. By utilizing the Personalized PageRank algorithm within its framework, HippoRAG ensures that when new information is introduced, it maps it onto an existing knowledge graph without overwriting or losing prior connection. This is akin to adding new books to the library, but ensuring that every time a new book is placed on a shelf, it is indexed in a way that still references older books and their connections. Additionally, HippoRAG's approach to retrieval allows it to integrate new experiences seamlessly. Instead of updating the entire library every time a new book comes in, it enhances the indexed connections between books, which keeps the overall structure intact. This way, the model can remember previous knowledge while also adapting to new information. In summary, HippoRAG helps prevent catastrophic forgetting by maintaining a balanced and interconnected knowledge framework, allowing it to integrate new information without losing the valuable context of what has already been learned. This ensures that the model remains robust and relevant in its responses, even as it accumulates more knowledge over time.
That analogy of the library really clarifies how HippoRAG maintains knowledge integrity while integrating new information. Considering all of these advancements, what implications do you see for the future of large language models and their applications in various fields, particularly with the enhanced capabilities provided by frameworks like HippoRAG?
The advancements brought by frameworks like HippoRAG have significant implications for the future of large language models and their applications across various fields. First, one of the biggest strengths of HippoRAG is its ability to continuously integrate new information without losing the old, which closely mimics how our brains work. This means that as we develop better models, LMS can become more like lifelong learners. They won't just be static systems that need to be retrained or fine-tuned frequently, but can adapt and grow with new knowledge over time. This could be beneficial in fields like education, where a model could keep updating its information based on the latest research or trends, providing more accurate and relevant responses. Additionally, HippoRAG's efficient multi-hop retrieval capability allows these models to tackle more complex tasks that require connecting different pieces of information in real time. For instance, In medical diagnostics, an LM could quickly integrate various patient records and research studies to make informed recommendations, enhancing decision-making processes. Moreover, the ability to handle long contexts effectively could lead to more sophisticated applications in areas like legal analysis, where models need to understand and integrate large volumes of information from various sources to provide insights or summary. Overall, frameworks like HippoRAG represent a step toward making LMS more dynamic, context-aware, and capable of performing complex reasoning tasks. This could not only improve the accuracy and relevance of responses, but also expand the potential applications of LMS in diverse fields such as healthcare, education, law, and beyond, ultimately creating systems that can better support human tasks and decision-making.
Those insights highlight the transformative potential of HippoRAG for large language models across various sectors. As we look ahead, what challenges do you foresee in implementing such advanced retrieval frameworks in real-world applications? And how might these challenges be addressed?
Implementing advanced retrieval frameworks like HippoRAG in real-world applications does come with its set of challenges. Here are a few potential hurdles and how they might be addressed. 1. Integration with existing systems. Many organizations already have established systems that may not easily accommodate new frameworks like HippoRAG. To address this, clear and comprehensive guidelines for integration could be developed, along with training for users on how to best utilize the new system. 2. Scalability. As the amount of data grows, HippoRAG needs to efficiently manage and integrate this information without compromising performance. This can be tackled by optimizing the underlying algorithms, ensuring they can handle large datasets and continuously updating knowledge graphs effectively. 3. Computational resources. Advanced frameworks often require significant computational power, which may not be feasible for all users. To mitigate this, researchers could work on optimizing the algorithms for lower resource usage, or develop lighter versions of the framework that can still deliver benefits without heavy computational demands. 4. Maintaining accuracy. Continuous integration of new information could lead to inconsistencies or inaccuracies if not managed properly. Implementing robust validation methods for new data can help ensure that only high-quality, relevant information is added to the system. This may involve developing automated checks or human oversight processes. 5. User trust and acceptance. Users may be hesitant to trust a new system, especially in sensitive fields like healthcare or law. Building transparency into how HippoRAG makes decisions and providing clear explanations of its processes can help foster trust. Additionally, demonstrating successful case studies can encourage acceptance. By proactively addressing these challenges, frameworks like HippoRAG can effectively be implemented in various sectors, ultimately enhancing the capabilities of large language models and improving their usefulness in real-world applications.
It's insightful to recognize the challenges and potential strategies for implementing frameworks like HippoRAG effectively. As we conclude, could you summarize the key contributions of HippoRAG in advancing the field of large language models, particularly in terms of knowledge integration and retrieval efficiency?
HippoRAG makes several key contributions to advancing the field of large language models, especially in terms of knowledge integration and retrieval efficiency. 1. Continuous knowledge integration. Unlike traditional methods that require repetitive summarization whenever new data is added, HippoRAG allows for the seamless addition of new information by simply extending its knowledge graph. This means that models can continuously grow in knowledge while maintaining the integrity of existing information. 2. Single-step, multi-hop retrieval. HippoRAG excels in performing complex retrieval tasks in a single step. This capability enables the model to gather all necessary supporting documents at once, significantly improving its efficiency. It outperforms existing methods by achieving higher retrieval rates, indicating a more effective approach to answering multi-hop questions. 3. Tool dying. Enhanced performance metrics. In benchmark tests, HippoRAG outshines state-of-the-art retrieval augmented generation methods, showing improvements in various performance metrics by up to 20%. Watch. This highlights its effectiveness in real-world applications where precise and comprehensive information retrieval is essential. 4. Reduced resource requirements. HippoRAG is designed to be more cost-effective and faster than previous iterative retrieval methods. This is crucial for practical applications, as it allows organizations to utilize advanced AI capabilities without incurring excessive computational costs. 5. Adaptability to new scenarios. The framework demonstrates the ability to tackle new types of tasks and scenarios that existing methods struggle with. This adaptability opens doors for more sophisticated applications across various fields, from healthcare to legal analysis. Overall, HippoRAG represents a significant advancement in the efficiency and effectiveness of knowledge integration within large language models, making them more capable of handling complex, real-world challenges.
Thank you all for joining us today. We've covered a lot of ground in this discussion, but I want to reiterate the key takeaways. HippoRAG has revolutionized retrieval frameworks by mimicking human memory. It seamlessly integrates new knowledge, preventing catastrophic forgetting. This continuous integration ensures adaptation to evolving information while preserving existing knowledge. HippoRAG's single-step, multi-hop retrieval, powered by the Personalized PageRank algorithm, dramatically enhances performance in multi-hop question answering tasks. Its cost-effectiveness, scalability, and adaptability make it a transformative tool for advancing large language models and their applications. This framework unlocks new possibilities in diverse fields. By incorporating human-like memory into AI systems, HippoRAG empowers them with continuous learning capabilities, paving the way for more sophisticated and intelligent applications.